Okay, so let's now go through the Term 1 Class Test 2022 for the Year 3. So this is one of the past year papers that we have that you are supposed to have done, and we can go through the answers now. So let's start with Section A, which is the MCQ. Answer is AACDA. So let's go through the questions one by one. Okay, they say an experiment was set up as shown below. Distilled water here, blue ink at the bottom. After several days, the liquid in the jar had the same blue color throughout. So actually what we know, for it to happen like that, diffusion must have occurred. So diffusion occurred. Which of the following statements best explains the observation? So they say that the ink and the water particles are in constant random motion. So this actually explains KPT, which then would explain your diffusion. Okay, so this is actually correct, but let's KIV first. Let's not say straight away this answer. We should always check through the rest as well. So B says the ink and the water particles have the same relative molecular mass. This is not true. Water particles, ink, how can it be the same relative molecular mass? It is not. Ink generally have a higher relative molecular mass. Next one, ink particles have a lower relative molecular mass than water. This is not true because it's supposed to be normally higher. So this is also wrong. The water particles diffuse in the spaces between the ink particles. Now, it's not just the water particles diffusing, the ink particles will also diffuse as well. So therefore, these also out. Because diffusion is all about from a higher concentration of the substance to a lower concentration of the substance. So it is, as long as the particles can move, it's not just the water that will be moving, actually the blue ink will also be moving as well. So therefore, answer for the first one is A. Next one, question 2. A flask containing a mixture of trichloromethane, chloroform, and water. Okay, so two different substances here. They are separated using a separating funnel. What conclusion can be made? So actually, for you to use a separating funnel, they must be immiscible. Okay, so if they're immiscible means that they do not mix. So actually A is the answer. But B, so what if they may have different boiling points, but to use a separating funnel is not about whether it has different boiling points or not. Trichloromethane has higher density than water. This is actually not true, because actually typically organic compounds will have a lower density, so this is not true as well. Trichloromethane is more volatile than water. When it's more volatile means it evaporates easily, but evaporating easily doesn't help you to conclude that you can use a separating funnel as well. So therefore, B, C, and D is wrong. A is correct. Okay? Next one, A3. So an experiment is set up using with a large beaker full of nitrogen inverted over a porous pot containing oxygen. So oxygen inside, nitrogen outside. What will happen to the water level after a few minutes? So we know oxygen is O2, nitrogen is N2. In this kind of porous pot question, you know it's all about the MR lah. So MR of O2, this is actually equals to 2 times O. 2O lah, 2O. Nitrogen MR is actually 2N. O is 816. Nitrogen is 714. So this 2 times 16, it will be 32. Nitrogen will be 2 times 14, it will be 28. So we know that nitrogen will have the faster rate of diffusion. Okay, so whenever you see porous pot, you know, I mentioned diffusion question, right? So if N2 diffuse faster, means that the gases will be going in faster than the gas coming out. So what is going to happen is going to push this water level down. Okay, it's going to push this water level down. So A says the water level falls, which is correct, because nitrogen has a higher relative molecular mass. This is wrong, so therefore A is out. Water level falls. Okay, this is true. Okay, why is it true? Because oxygen has a higher relative molecular mass than nitrogen. Actually, this is correct. Okay, so B is the answer. Oh, did I put the wrong answer here? Actually, it's not supposed to be B. My bad. Okay. So water level is falling because the oxygen has a higher relative molecular mass than the nitrogen. The water level rises so we know that rises out, therefore C and D cannot be the answer. Okay? Next one, A4. Hydrogen can form both H plus and H minus ion. Which statement about these two ions is correct? H is a 1-1. So if I form, so it has 1 proton, 1 electron, 1 neutron. H plus actually has 0 electrons, because in order to become H plus, it must have minus 1 electron. For it to become H minus, it must have gain 1 electron, it must have 2 electrons here. So H minus has actually wrong, it's not 1, it's 2 more electrons, so this is not correct. H minus ions form when hydrogen loses an electron. This is not true, it's supposed to be gain. H plus has more protons than H minus. This is not true, because proton determines what element it is, right? Determines the element. So if both of them are hydrogen, they actually have the same number of protons. Last one is H plus has no electrons in its first shell, so you can see here, so therefore this is correct. So question 4 answer is D. Last one, question 5 for MCQ. A sample of pure compound was heated until it's completely molten. Molten means turned liquid. Okay. It was then allowed to cool until it was completely solid again. So that means actually this sample started off as solid. Then you heat it up until it becomes molten. Then after that you cool it until it becomes solid again. So it's solid to liquid to solid. The graph below shows how the temperature of the compound changed with time during cooling. So their focus is on here, liquid to solid only, during cooling. Which segment of graph does the compound exist as the liquid state? So we know that when it's changing state, it's a mix. So down here will actually be liquid plus solid. When it's completely cooled, it's solid here at P to Q. This is where it is liquid. So which segment of the graph does the compound exist in the liquid state? Answer will be P to Q. Okay, so just take note of that. Okay, B1. The following diagrams represent the particles in different substances. Use the letters A, B, C, D to answer the following questions. Which one represents a mixture of helium and argon gas? Helium and argon gas, they are both noble gas, so they don't bond. So actually they are monatomic, means that they exist as a single atom. So you can see here there's a compound, this is a compound, triatomic. So actually the only possible one would be C for question 1. Okay, helium and argon, they're actually monatomic, so just take note of that. Next one, which diagram represents a mixture of element and compound? So if I look at A actually has this circle, big, small, this is a compound. 1 circle, dark one, this is an element. 2 circle combined like that, this is also an element. So A is actually a mixture of elements and compound. Actually 1 compound only, so actually answer will be A. Okay, so actually shouldn't be compounds, it should be compound, 1 compound and okay, so 1 compound and then 2 different elements, so that's why it's A. B itself actually is a pure compound, so this one only made out of 1 compound only. This one is actually made out of 2 elements, so 2 elements. This one is made out of 1 element only. Okay, this is an element, 2 of the, so this is a diatomic element. So which represents nitrogen gas? Nitrogen gas N2, that's why it is D. Okay, nitrogen gas, take note, D, because it is part of the H7 family. Part 4, which diagram represents water vapor? Water vapor represents water. Water is H2O. H2O, obviously, it will be B. Okay? So B over here. Next one, B part 1. Name the technique used to separate the substance in diagram A when a mixture is in the liquid state. So if it's a liquid state, you want to separate the substances. Okay, you got 3 different substances, right? So actually what you'll do is fractional distillation. So normally liquid, to separate liquid, right, is to separate different liquids. Okay, there's a few ways to look at it. You can use a separating funnel, but this is only if the substance do not mix. If the substance mix, then you can actually use your fractional distillation. So in this case here, you actually not sure whether it will mix or not. That's why I'll use fractional distillation as the better answer here. Okay. Next, explain the principle behind the separation technique in B part 1. So for distillation to work, or fractional distillation to be more precise, the substances must have different boiling points. So that's the first point over here. Then what's the point of them having different boiling points, right? So the lowest boiling point will boil and distill out first, while the highest boiling point will boil and distill out last. Okay, so see the way how they phrase here in terms of explaining what you would tend to observe for the fractional distillation. So 1 mark for saying that it is different boiling points, as mentioned here. The other one is saying describing which one will come out first, the lowest boiling point. The other one is the highest boiling point will come out at the last. So this is the second mark. Okay. Next, B part 2. Paper chromatography was carried out on 3 samples of wastewater using water as the only solvent. So water is a solvent, huh? Results are shown on a chromatogram. So I got A over here, the spot remained at the start. B has separated into 2 spots. C has separated into 2 spots. Okay, so I know that B is definitely a mixture. C is also a mixture as well. A, what I know is that the spot didn't move, right? So generally, I think this spot, I don't think this spot is definitely insoluble in water. Okay, that's why the chromatography has no results. What other thing do I know is that if I were to take my ruler and measure, okay, take my ruler. So you know that these 2 spots are of about the same height. Actually, you can use a ruler. Let's use ruler. Hoi. So you realize for this one here, oh no, I shouldn't do that. I put it lower. Okay, let's draw the line nice, okay, somewhere about there. Okay, so I can keep the ruler. Let's go back to my pen. So you know that B and C has one component that's the same. Okay, they say the table below shows the RF value of some metal ions in the aqueous solution. So I got nickel, cobalt, copper, cadmium, and mercury. Okay. So calculate the RF value of the spots in sample C, hence determine which metal ion likely is contained. Leave your answer in 2 decimal space. So first one, I got 2 spots here, so maybe I take my ruler again. So the first spot, or the spot at the bottom, this one is about 8 cm. This one here is about 9.5 cm. I know my solvent front is until 12. Okay? So take note, always use your decimal place properly. So it's 12.0. So lowest spot is 8 divided by 12 is 0.67. The highest spot is 9.5 divided by 12 is 0.79. So there's no 0.67 here, therefore lowest spot there's no metal ion. Okay, cannot. There's so the lowest spot is not contributed by the metal ions here. For higher spot, it is 0.79. You realize the same as cadmium. So you must identify cadmium as the higher spot, the metal ion that contributed to the higher spot. So 1 mark here, 1 mark for 0.79 plus the cadmium identification. So take note, this is where the second mark goes to. Okay, so if you just write 0.79 without cadmium, or you just write cadmium without 0.79, you're not going to get your marks. So take note. And they already say leave it in 2 decimal place. So you're going to put 3SF here, then you definitely mark down because they already say 2 decimal place already. Okay? Next, explain what the results on the chromatogram indicate about purity of sample B. As I mentioned, B is impure because it contains 2 spots. Okay? So 1 mark by saying impure plus 2 spots. If you just say impure alone, not good enough because the word is explained here. You need to explain why is it impure as well. How do you know? Next, after paper chromatography, sample A remained as a single spot on the start. A student stated that it's impossible to determine the purity of sample A in the experiment. Okay, based on this chromatography, yes, it's impossible because sample A could be insoluble in water. So if it's insoluble in water, it will not separate, it will just stay as a single spot, right? Okay, that's why student A is correct. So what can we do here? We can use a different solvent, and if there's only 1 spot using the different solvent, then it is pure. So suggest how. Okay, so actually using a different solvent would be sufficient in terms of suggesting, but the thing is you need to suggest how you can determine. So it's not just suggest how to show, You need to explain how this will actually allow for the purity to be explained. Therefore, the word one spot here is important as well. So we are looking out for different solvent plus your one spot sin. Then to know that is pure. Okay? Next, B3. Alcohols are popular choice for perfume solvent due to the high volatility. It means they easily turn to gas. Okay, so those of you forget, easily turn to gas. That's what volatile means. Ethanol is an alcohol that has a melting point of negative 114 degrees Celsius, boiling point of 78. Sketch a graph against time where the ethanol is heated from negative 200 to 100. So you realize that when it starts at negative 200, it should be a solid. At negative 114, it will turn into it will be melting. So I'll have solid and liquid state here. Then once it crosses 114, this becomes liquid area. This is 0. Now it's 78. Now it's 100. So once it hits 78, it will start to boil. That's where you both have the liquid and gas state at 78 degrees Celsius. Then the last part here is purely gas where it's fully boiled. So what we want to see is both axes labeled with units. So remember time slash the units, quantity slash the units. Okay, take note of the slash there. I want to emphasize on it. Next, you must label the temperature on the y-axis because you already know they want 200, negative 200 to 100. So I must have these two. I know that I must have my boiling point and the melting point, which is these two as well. So all this data needs to be included. And last one is the correct shape, where you should have flat line at negative 114, flat line at 78 degrees Celsius. Okay, so that's where the 3 marks goes to. Next, describe and explain the shape of the graph at 78 degrees Celsius. So 78 degrees Celsius, the line is flat. So you say temperature remains constant. That's the description there. How to explain it? Energy absorbed is used to overcome forces of attraction. That's one part of the second mark. The second mark, you need to mention that there's no change in the average kinetic energy of the particles. So the first one mark is easy. Temperature remains constant. The second mark goes to these 2 points combined together. Okay? So that's where the 2 marks goes to. Next, describe the movement and arrangement of ethanol at 0 degrees Celsius. So at 0 degrees Celsius here, you know that the substance is a liquid. So I just describe liquid lah. So this is the movement. So slide over one another. Closely packed and irregularly arranged. This is the arrangement. So once again, I emphasize when you talk about arrangement, it's not just saying that it's irregularly arranged. You need to tell me about the packing. So arrangement includes packing. Includes packing. So just take note of it. Okay, B part 4 now. So complete the table. So actually they give you 23 and 11, 40, 18 and 17 here. Then also fill up the rest. So sodium atom, if my atomic number is 11, my proton number will also be 11. And because it's an atom, the electrons and the proton must be the same. How to find neutron? Just take the mass number minus the atomic number, you will get 12. So sodium atom is easy. Next one, calcium ion. Once you see ion, that means you know that proton is not equal to the electron here. Okay, so they give you electrons is 18, mass number is 40. How do you find the atomic number? Atomic number is also your proton number. And actually, how do you know calcium proton number? You just see periodic table. Okay? Proton number determines what element it is, or vice versa. So if I know that is calcium, the atomic number must die be 20 lah, because you see periodic table is calcium 2040 ma. So the atomic number must be 20. Once I know atomic number is 20, I know proton must be 20 lah. Once I know proton is 20, neutron is just 40 minus 20, then you get 20 over here. Okay? So take note of this important point here. Next one for chloride ion. I don't know the mass number. If you go periodic table, it writes chlorine 1735.5. Then like, oh no, crap. If the mass number is 35.5, should I put 35.5 here? Answer is no, don't put 35.5. Okay, because if you write 35.5, you're going to have issues with the number of neutrons. So what they did here was they give you atomic number 17. They gave you that the number of neutrons is 20. So first thing first, atomic number 17 means proton must be 17. So I got 17 over here, 17 over here, right? Next, neutron plus proton actually give me my mass number. So I realize 17 plus 20 will give me my 37. What you're left with is the electrons over here. How do you know it's 18? So for normal chlorine atom, so for atom, chlorine atom, right? 17 protons, 17 electrons, right? This is the normal atom. Electronic configuration 287 because of the 17 electrons. When it becomes an ion, it's so that the last shell, the outermost shell, the valence shell can be fully filled. So how to make the valence shell fully filled? Actually, it gain one electron. It becomes 288. So therefore, if it is 288, this is chlorine Cl minus, right? How many electrons does it have here? It's 18 electrons. Okay? Oops. Let me go back up, my bad. Okay. 18 electrons are, sorry, I just now, oops, the thing disappeared. Okay, let me rewrite again. So, this one here, for the atom, the proton is equal to 17, means I must have 17 electrons. The configuration is 287. For it to become ion, the last shell must be fully filled, so it must have gained one electron to become 288. So if you look at 288 here, it means that it has 18 electrons. Therefore, down here, 18 electrons. Okay? So this table here, 3 marks, most probably is every 1 row 1 mark. Every 1 row 1 mark. Next. B part 1, define atom isotope. So you realize defining isotopes keep coming out, so just take note of it. Atoms of the same element, same number of protons, different number of neutrons. Okay? Part 2, write the nuclide symbol for the isotope of chlorine, 18 neutrons. So 18 neutrons means there is a Cl, 17. P is 17, E will be 17. Neutron I know is 18. So the nucleon number at the top must be proton plus neutron. It will be 35 here. That's why it is Cl1735. Okay? Last one, write the electronic configuration of sodium atom. So sodium atom, the electrons is 11. So it will be 2, 8, 1 over here like that. Okay, so quite a last good question to end off with. So that's all for this paper. Okay, that's all.